Okay, let's start with the shocker du jour. Muons and electron showers. We created them. The black one is the muon, the white one is the electron showers. Guess what you can do with that? These are the physics of electron showers. If you can do that, which we did, you can create a few hundred giga-electron volts to a few trillion electron volts. That's because of the energy of neutrinos. There's muon neutrinos and electron neutrinos. We want the electron shower ones. This little u means energy. When you come through at a very low energy of these electron light, basically a pulsed red laser, when you hit the Venturi, it goes right up through the roof because we have separated the white from the black. Same thing here. This is the number of electrons coming through. There's a significant amount, but as soon as they hit the Venturi, zip, right up through the roof. And what does that do to the energy? The energy comes up to here from down here. That's an increase in energy, staggering. We should be able to get free energy. Don't forget, I'm not making any guesses here. We did separate and create using pulsed red laser through the Venturi, and this is what we got. Exactly what they wanted to see. The muons go sterile, the black ones, and the electrons go into the showers. I'm going to go into the very deep details with this. It's all being talked about now. Dipole electron flood theory. They're starting to try to twist it around here and there, but it's complete. It's done, and I will show you. It's been done for quite some time. Good morning, my intellectually superior friends. Today we're going to talk about the new particle they have discovered. Defies all the rules of what it's supposed to do. It's called a semi-Dirac. I'll show you what a Dirac is, and then I'll show you what a semi-Dirac is. I'll show you what they say, and I'll show you what I say. Okay, let's take it from the top. They're talking about semi-Dirac particles. Well, this is a Dirac. It has a white side and a black side. Now, the matter actually is here. The energy is here. And they are totally separate. Matter and energy are totally separate, different things. And I will show you that in extreme detail. Okay, so we're going to be talking about semi-Dirac fermions. Fermion means energy. All right, so semi-Dirac. So what is a Dirac? Semi means part of a Dirac. Well, let's see what a Dirac is. And I'll show you the fermion portion. Now, the other thing is, have you ever heard that light just spins around in a circle? I always thought it flapped like a wave. It does look like a wave, but it does spin like a circle. And who knows that? Well, I do, because of our light experiments. Let me show you the semi-Dirac fermion, and I will show you how light spins, and light is a particle, and it is made of Diracs, back to back. Okay, let's just go through this clinically. We're talking about a semi-Dirac. That means not a complete Dirac, a portion of a Dirac. That is the energy portion. This is the matter portion. They have it backwards. This is from Fermilab, just backwards. So you saw the Dirac. Now here's what, again, this is from Fermilab. And they saw these particles. This glowy one has no mass that they can determine, and is all energy, and this is all mass and no energy. It has a glowing part. This is fixed, never changes. This one can get big and get small, as we saw in our experiments. Now these were from head-on collisions of gigantic particles like this. Boom! And they saw the particles. They have no idea where they came from. We see them starting from light. This is light. So instead of being up in here, we're down here. So we get to the point where they wanted to get to, which is these particles. They've seen them, but they see them in a big pile of debris. Let me show you what they do, and then I'll show you what we do with our experiments with light. We just use light. Let's see what they used. All right, here's what they did. They go around and back and around and around, and boom, they hit these things together, which they call protons and neutrons. And what they are really is a ball of these tiny little dipole electrons. And when these two balls hit together, they just smash into bits and pieces. Some chunks come out like this. They call them X particles. They could be any size they want. Some particles come out like this, which are photons. Some particles come out in the semi-Dirac particles, which are just the little bits and glowy parts. Some of them are very energetic, blue, less energetic, green, not energetic to speak of. Red is a very slow light. See this here? Blue is up here. That's got a lot of energy. Down to the red. Not a lot of energy. So what they see is debris. They call it a particle zoo. They can make heads or tails of it. No way. They've been studying it for years and years and years, and all they see is a pile of debris. We started down at that, right there. We started with that particle. All right, this would be extremely simple to test. Within a week to 2 weeks, we'd know 100% one way or the other. And if it works, we are golden. If it doesn't work, well, it's just another thing that didn't work. I say, if what I'm saying is correct, we should be able to have a device like this we could carry around, portable, clean, cheap, well, free. Once you start it up, you just never have to stop because it would feed off its own self. The laser would be putting in all this high energy, and we'd be squeezing just the energy out like a toothpaste tube on this side into our battery. It has no weight whatsoever. Now you could have a battery in here, but you wouldn't even need it. Once you fired it up, it would just continue to pump energy out because it would feed up its own self. You'd need some little device in there to power the laser. Now, depends on how many lasers you had in there, how much energy you get out. But this is what happens inside. We need to harvest that white right here. That white has no weight whatsoever and has all the energy. And all you're doing when you generate energy is you suck the black away from the white and you put the white into your electric vehicle, whatever it is. The white has no mass. It has no weight. All right? When you fill your car up with energy, it doesn't change weight. 4,000 pounds before it gets charged, 4,000 pounds after. You drive it all day, still 4,000 pounds. Fill it back up, 4,000 pounds. Energy electrons have no weight to speak of. They cannot find the weight. In Fermilab, all of them say that. CERN does too. And I do too. This is how simple a Venturi is. And you could have several of them in a row, but what you need to do is have a pinch point. Now, this just shows of smacking up against a flat plate. You wouldn't do that. You'd create a Venturi. Now, we use the rounded ones. They're round like this and rounded like that. And when the light came in, it had to go through there. It squeezed itself and came out the other side in extreme high energy showers. That's as simple as a device you can get. And it kept the black away because it couldn't get through the Venturi. You have to tune that to exactly the right size. So what I just showed you was the Venturi right here. And it comes in. Now we have it angled like this. So you got the angling coming in. And that's exactly what they just did in this recent experiment, where they showed the light going backwards and going forward and only the mass going forward. And it's a very simple thing to understand once you understand dipole electron flood theory. I'll show you the reverse energy and the forward energy right now. This one picture shatters physics. Why? Well, first of all, this is a light wave. All right, there's always been particle wave duality. They can't figure it out. They think it flaps and so forth. Well, it spins in a circle, first of all. Secondly, it has a magnetic field that surrounds a particle, and in this case, the particle is being accelerated due to our Venturi. Now, the particle itself is being sucked directly out of the wave. All right, see the wave is being elongated and just finally it just says, I'm gone. Boom, it takes off. Now, which is extreme acceleration of light, not allowed by Einstein or anybody in physics under the current model. Now, when that light hit here, we can see very clearly there's the blacks and the white. And I showed you those in their attached form before. Now, what happened here? Bam, 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 pulsed laser. The black pushes the white. The white can shrink down to fit through the Venturi, which is very tiny. and the black can't make it through. And it just piles up here, and bam, 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 bam. They call it the preceding muon showers. And these are the electron showers that just get squirted through here. Now, they will not stay separate for very long at all. They reattach almost instantly to the black here. Now, where did that black come from? That's the key. You got to have a whole bunch of extra black floating around, because I don't think that black jumped from here over to here. Originally, they were together. I showed you how they are normally together. All right, and that is now, they're separated. And that is fission. Whenever you separate something from something else, it's fission. Whenever it goes back together, it's fusion. In the middle here, we have the raw electricity. That is raw electricity. That's what you want to drive your car with. And when you can separate these two, which is the strong nuclear force, because it's inside the nucleus, and it is strong. And if you can pull that white away from the black, that's when you get electricity. That's all you're doing when you generate electricity. You're pulling the white away from the black. Never changes the weight of anything that you charge up when you put this into it, but it gives it a hell of a lot of energy. So I said I can show you light traveling both directions at the same time, and I can show you the mass going forward, but only the light going back. So can I do that? Yes, I can. You see these little lines, these waves back here? You see the curve to them? All right. This was my field, was electronics and electrical generation, high frequency, generation, 200 cycles per second versus 50 and 60. I know this stuff pretty well. This right here is what's called reverse EMF, electromotive force. Electrons, motivating, moving, force, pushing. All right? And that is because of the bounce. All it is bouncing. It bang, comes back. And you see how far, this is powerful. This is literally a subatomic nuclear explosion. We divided the black from the white, and it came back here. And this is just like a bomb going off right here. It's literally the same thing as a bomb going off. And it's sending these waves back, just pew. And that's the only reason these are even showing up. Because this one's showing up because it's being dragged forward hard. And when it is, it's pushing into everybody else's fields. You see all these little fields lighting up? Well, that's because this field has to push through it. And it's going so fast that these are stopping it and crushing its field. And then it just says, I'm out of here. And it takes off right out of its own field because it's going too fast to drag its field with it. These are light in the regular light realm, and you don't even see them. You don't even see them. They're here. They're all coming forward. But you don't see them because now you see them because they're being radiated backwards. It's not because this one you would never see either. The only reason you see it is it's dead nuts, right in line, boom, with the Venturi. You see that? Zoom. There is fields everywhere around here. They're all over the place. And the only reason you see them is because of the reverse electromotive force. So this thinks it just hit a wall. You don't get light until you bang into something. Light just goes basically without being seen until it hits something. If you have a lot of dust in the air and so forth, you'll see them flicker on and off as the light goes through it. Just like in a barn, you see the little lines in the barn, you see the light flickering on the dust and so forth. But normally, light just sort of floats along until it bangs into something, then you see the bounce. This is the bounce. That's all it is. Only this is extreme bounce. That's bounce on steroids. All right, you see how it's just amazing how powerful that bounce is. But these fields are everywhere. They're everywhere. You just don't see them. All right, just to sum this up, the particle is coming through here, which is the light photon. It smashes here, explodes, divides, and comes right back together. And only the white can fit through here. The black has all the weight. The black is literally dark matter, and it is all the weight, virtually. There's got to be some weight to that white, but it's very, very small. I mean, way small. And here is where you have to grab that white. And if we could put a harvester right here, we might be able to get free energy. But you can see the mass continues. The light goes back and creates that huge reverse electromagnetic force. It's unbelievably powerful back here. I mean, that's an subatomic bomb. That is a subatomic bomb, my friends. And it will not hurt you because they rejoin all together. And an atomic bomb, why you get hurt from atomic radiation is because it kills the enzymes in your body, the bacteria. It kills the bacteria in your body. That's why you get acute radiation poisoning, which means you're around something that gave a pulse like that. And you don't fall over dead. You get sick in about a day or so, or a few hours. You start throwing up and vomiting and diarrhea and all that because it killed all the digestive things in your intestines and everything. That's when you get sick. Now, if you have enough to recoup from that, you're okay. If you don't, you die because you don't have the enzymes in your body to produce the chemistry that you need. This is all dipole electron flood theory. It goes into biology, anatomy, history, everything, because it affects everything that we have ever heard about everything. If you don't understand gravity, how are you going to understand quantum physics? And if you say that the universe is empty and void and light cannot slow down, so the Webb telescope is seeing everything perfect and knowing that we're expanding so fast now, we're going faster than the speed of light. Everything is so wrong, it's just unbelievable. And they stick to the standard model. Does not work. So I showed you this. If that would work, I think we get free energy. And we can harvest it right there, right in a little box like this. And you don't need much of this to do a lot of work. This is just as energetic. I mean, it's just raw energy. So I showed you we can accelerate the light. I showed you how the Venturi works. Now, what does CERN say? Well, they're showing the same thing. They're starting to understand. Well, I actually went to the University of Geneva, and I told them all the stuff we were doing. And we were working with photons, not protons. And I showed them all the pictures I just showed you. This goes back 10 years. Now, here's what they're showing. Base tracks of electron showers. They come in low energy. What does that mean? They don't have much energy. And then what happens? They just automatically go up to large shower cones of high energy. High energy from lower energy. Low to high. So if you can do it for nothing, you just took a chunk of low and turned it to high. Well, why can't you use that chunk? Which we can. This is the muon base tracks. They say they have muons have earlier showers. They hit and they bounce back. This hits and creates huge showers, as I showed. All right, so could we actually create energy? I think so. Because we're talking about right now data visualization of the number of base tracks at shower maximum layer. All right, so we go from low energy to high energy, supposedly. This is what they say right here. These are the number of electrons in the shower, the max number. All right, so it comes in at this, and then they start to get bigger and bigger and bigger, and then all of a sudden it squirts through, and they go up to that many electrons. All right, so that's the number of electrons created from this number of electrons once it makes the shower straight up through the, I mean, it's a direct straight up line, instantaneously at the Venturi. Now, what happens in the energy? Do you see that? That means energy, that little U. Number at the shower maximum energy. Well, down here, there's not a whole lot of energy. Very little energy. And then it hits the Venturi right up through the roof. Why can't we use that energy? We're right at the Venturi. We just grab it right here and use it. We didn't do anything to change it. We didn't do anything. When you're taking a generator, I have a generator, and a lot of people have generators, and you turn them on, and they start running. You let them warm up for a few minutes, and it's just sitting there going, Now, you flick your house on. I have one that I plug it in and I just click it on and the whole house comes back. It's not big, but it's enough to do the job I need. But I had them put in an outlet where it's 220. Boom, I put it right in there. I turn it on, the whole house comes back. Well, guess what? As soon as I run that generator, just a homogeneous, just a hum. Now, all of a sudden, I click to use that energy. And I hear, and then all of a sudden, it comes back to sort of smooth. Now, if you hit something big that wants to suck a bunch of juice out of there, you're going to hear that again. What's that? It's pushing of the electrons against the field to separate the electrons. And it takes a hell of a lot of energy to do that. Just a hell of a lot. Well, we didn't do anything whatsoever to create this effect. That's energy from here to there. Why can't we look at this? Why can't we even look at it? That's my issue. Now, don't forget, we started with the photons, which is the tiniest little particles. They started with these huge things and they got all kinds of debris. Now, here's what happened. They got all that debris and they could see these little, they called them Higgs fields. But they're coming here, bam, and just everything goes flying, but they see these little circles and they say, wow, these are Higgs fields. But this is just something they drew. Now, we see them too, but we see them, the real Higgs fields. And that's because this light is coming in and it's recombining with the black. It was originally only white coming through, and this now is recombining with the black. The reason I took this shot and kept it was because the blue is being pinched. You see this? These fields have mass, and that has mass. And between the interaction of the crushing of these two fields against this field, it crushed this and elongated it. You see how they're kind of flat? And elongated it. And now it came back. I mean, some of this stuff is fascinating. I have another one that shows an anti-particle, which is the only one I have, only one of us. Okay, this is Higgs on steroids, I call it. This is the light coming through the Venturi. We're seeing it recombining with the black. You see that little tiny spritz coming out here? And bang, it hits that. They just start to make these disks. And when they do, they create an inner field. All right, that's why you're getting this disk. It's creating an inner field. I've been trying to work on that, figuring out why, but it does. Now, you see that little particle? And they're all going shooting everywhere. They're shooting everywhere to reestablish themselves as actual physical particles, which are blacks attached to the whites. You can see some black particles coming through too. You can't completely eliminate them unless you had a really, really finely tuned Venturi. This is about as good as I've ever seen in Rod's work. Rod Warren did this. He did all the experiments. I did some, and I had some other people do some, but nothing like Rod. Rod is the guy that deserves the credit for this. And he was just doing it, looking for other things in light. And when I saw what he was doing, because I'm into this since 1970, my particle physics goes back to 70, or even earlier than that. I got out of the Army in 1970. I was in nuclear missiles, servicing the missile sites. And it was primarily precise power and generation of off-site energy. So we were off the grid, but it had to be perfect. It couldn't be 60 cycle. It wasn't precise enough. We had 200 cycle. So it's just, the other stuff was, we were straight across. So there was no, well, anyway, very precise. Now, this is backwards again from what Fermilab talks about. This is the reassembling of the black to the white, or actually to the white seeking the black. Wherever it's coming from, I don't know. It's all over the place here because every one of these Higgs fields has a black and a white. They're all turning back into the particles. And they may even be actually photons. I don't know. At this point, I'm not sure whether they're just electrons now, dipole electrons, or are they actually photons? They look like they could be photons because coming in, they have exactly the same look, which are photons. So coming in, we can see them right here. You see that? It has the exact same look coming in as when they reattach coming out. And I know these are photons because we saw the photons. So is that a photon? A Higgs field is actually a photon reassembling? I think it might be. You know, I am pretty sure that these are reassembling photons. They could be just electrons, dipole electrons, because dipole electrons are heat. They're not light. Dipole electrons are heat, and so this very well could be just dipole electrons being diffused as heat into the air. But right here is just raw energy. That's what we got to get, is right there. I think I've shown pretty well that this is an enormous increase in energy, and CERN and Fermilab and all of them agree, if you can do what I'm talking about, this is the consequence. And that means energy at the shower maximum. We did nothing whatsoever to create that shower other than funnel the particles into a pinch point that was so restrictive that their fields crushed each other's fields and created a nuclear subatomic explosion. At CERN and all that, they go this way and they go the other way, and they end up smacking together, and they just get clouds of debris. They get the same things we get, but they just have a bunch of other junk. So it obscures everything that they're looking for. We started with the particles that they are trying to find. And they claim, oh, no, Roger's just a crazy guy. I've been told I'm an embarrassment to science. As far as I'm concerned, that's the Fermilab particles. And this was long ago. This is 10 years ago I put this up. Light is dark energy and matter in the vacuum of space. There is no vacuum of space. These are the particles. These are particles. Here's what you got. Let me show you something about space. Hold on. Okay, my friends, it's again Roger the Disruptor. And what am I disrupting? Well, global warming, I don't think is understood well. I just showed you the particles here, and they are particles. They have mass, they glow with energy as they push through the particles in front of them. These white particles are drawn to the Earth because the Earth is ground. If you take electricity right to ground, which is the Earth, lightning right to ground, which is the Earth, static electricity collects on you, which are extra electrons, ground, they seek ground. Now, so what is it, where do these come from? Well, they come from the sun. These are particles of light. So, let's talk about the interaction at our ionosphere, at the out edge of our atmosphere. This is the outer edge. The religious people would call it the firmament, which is fine. That's okay. I can go with that. I'm religious too. So, but I know the Earth is round and so forth. There's a lot of stuff that just, you got to be realistic. And they did talk about the firmament. Yeah, but it's right there. And what does it mean? It's the edge, which is the firm edge of our atmosphere, scrubbing against all the dust and particles and the masses that are coming at us from the sun. Light is dark energy while traveling from the sun to Earth. It's traveling here, banging right against, and this was 10 years ago I did this. It's banging right into this layer. Well, what happens when that particle crashes into these particles at the edge of our atmosphere? It gets 3,000 degrees up there almost. Did you know that? At 3,000 plus up here. And then because it's a dipole, the hotter this gets, the colder it gets here. And just below it, in this another layer, it goes minus 110 degrees. And then another layer, we get the heat. And then that heat transfers into the Earth, which is the ground. And of course, this is the Gulf of America. Now, that particles coming from space, this is where it's hot. And it's getting hotter there, and it's getting colder here. That's why we're getting these huge chunks of ice and everything falling out of the sky, hail and thunderstorms and lightning and all that. It's scrubbing like crazy here, it's scrubbing like crazy here, and it's dipoles. So space is, basically cold. Hotter than hell, 3,000 degrees. That's why things burn up coming through that layer. Yeah, and they can do coatings and so forth on the space shuttles and all that stuff. They can go through that. That's not a problem. But it is for something that has no resistance to this intense heat. And that's why the meteorites burn up and so forth. Anyway, here it gets cold. And then it gets hot, where we are, and it's getting hotter and hotter. Hotter it gets here, colder it gets here. Colder it gets here, hotter it gets where we live. And then the Earth is supposed to absorb that, but it doesn't. The Earth is too hot already. It can't absorb anymore. It's getting hot where it's supposed to be cold. It doesn't want to absorb electrons anymore. It's just there's too many electrons in the Earth, so it's pushing them back up. This layer gets hotter and hotter and hotter. That's going to be us. Now coming through, the particles coming through, there will always be polarized towards the Earth. They call it up and down spin. So the white particle will always be down, or the white particle will be up, like here. In this case, the white particle is down. When that charges up just a little bit more, you see how it's real glowy? It's going to go bloop, and this one will go in front. And then you're going to have upspin. So we got down spin heading towards the Earth. It's always going to be on that polar plane. It's always going to be headed towards the Earth. So the white one, it's never going to be like this. And I can show that and prove that as well. So do you understand what I'm getting at here? You got all these we got all kinds of different particles of light coming through here. And they get absorbed by ozone and all kinds of things because they're pushing back at the light. Light slows down very easily. And space is so saturated with particles and light and dust and everything else. Well, I'll show you that too. This, my friends, is what is right in our neighborhood. That is our moon. And all this stuff, I don't know. I do know these are magnetic fields. Fields create these exact magnetic fields with the poles. Now, what these lights are in the sky, I don't know. What these fields are, I do know, are fields that interact with other masses. And everything is a dipole. You see black and white everywhere, black and white everywhere. And he also, this was Dylan, which was Rod's nephew, and they don't want to be involved in this, and I don't want to push anybody into anything, but boy, I'll tell you, they were something. That's another dipole, and I believe that is Venus. And I have my reasons for believing that. But everything's a dipole. It's a dipole, dipole, dipole. Again, very strange stuff. Very, very strange. And this was just done with a cell phone because it uses CMOS, which works very well to do this particular job. As a matter of fact, CERN upgraded to use CMOS. Now, again, the physics here we're up to neutrinos, electrons and muons. We've already started at the neutrino phase. And when you get up to this energy, it goes from a few hundred giga-electron volts to a few trillion electron volts. And you're starting with millions of electron volts. The increase in energy is just stunningly astronomical. But they're starting with proton-proton collisions. Then they have to create these, what they call hadrons. And then they have to decay the hadrons. And then they have to create the flux energy neutrinos. Then they have to do this and do that. And then finally they get down to where we started. All right, and then they say, wow, now we can really get some energy. Well, guess what? They're right. Because once you hit there, and that's at the Venturi, that's energy. That little U right there means energy. Now, don't take my word for it. That U stands for the internal energy. It's a symbol used in thermodynamics to denote the total energy stored within a system, the total energy, including kinetic energy of its molecules and the potential energy associated with their interactions. That means that's the energy. It's like your battery. How much energy can your battery produce? Well, your battery, in this case, can produce gobs and gobs. Once you go through that Venturi, boom, she takes right off. You get all these electrons showering, creating all that energy. I can't see why we can't use this to get free energy. I got to be honest with you. It sure looks like a winner to me. But we need somebody to do the engineering. And I've been trying for 10 years to get that to happen. And it's been a very, very difficult pushback. When I found these particles and I saw them at Fermilab, I said, geez, I found the particles. And it didn't go well. And this is right here. It's exactly what they say, what we did. The muons and the electron neutrinos attached together, the black and the white. The black goes on its own, called a sterile muon. The electrons go into the shower. It can't be any more clear than this. We accelerated the light, divided the light, created electron showers, created the muons backing off. We need to harvest it before it becomes back into those Higgs fields, which is the reattachment, not the disassociation. They think the Higgs fields are formed when they break apart. No, they're formed when they come back together. So this is where we have to have the receiver right here, the harvester. Because once it gets back to the Higgs fields, you're back to being just particles of light, which have, they have energy, but they're certain, not like this. That is completely separated. This is exactly what you do when you turn on a generator. You push all the black out of the way and you just get the white. Now there is a taste of black coming through here, which I don't think would be too much of a problem. However, this is where you need some engineers. You need some people that can do a little engineering. They have equipment, a little knowledge, and they can create and do experiments and testing. It only take a couple of weeks. And within a day or two, you'll know, can we actually get an increase in energy here from where we started before the Venturi? All right, so again, I've shown this, I know, a zillion times, but what here is this right here, right that spot. Right here is where it starts to whack, and all those fields show up, and then they make the Higgs fields. Now, what we have to do is be here. We got to be before it reattaches itself, because right here is its energetic phase. Once it hits these, it's like banging into a wall, and they turn back into, electrons or heat or whatever. But we got to get them right at their maximum, somewhere way up in here, where we got all the energy. I mean, I don't mean to keep showing this over and over, but it just seems like it bounces off of people's heads. They just can't get their mind around it. You come in with low energy, and then when you hit that separation zone, zip, all right, the showers just go right off through the roof, and the energy follows it. The number of electron, the fermion portion of the Dirac, the white portion, those are the energy. The number of those that you can collect in one spot at one time is your energy. We just squirted them, but you got to grab them. So we need some engineers. We need to be able to use some of these new perovskite thin film, the transition metals in here, that they absorb all different layers of frequencies, and then you can funnel that down through that little device I was showing. Something like that. You could put thousands of those lasers inside of here, and I don't see why you couldn't power a car, a house, maybe even an airplane with something like that. I'm telling you, the energy change is just staggering. How much energy is in the raw electrons. It's just phenomenal how desperately they want to be reattached to that black. That is the strong nuclear force. You will never get these two to break apart, ever, except for what we did, or cosmic rays, or particle colliders. But we just got lucky when Rod did his Venturi. He was trying to do a double slit experiment, but he didn't use flat plates. And he didn't know what he really was doing. He was just playing around. But when I saw that acceleration, I went off to, and he worked with me, got to be 5 years or more. And, you know, you can only do it for so long. But when I saw that, I can't remember, but I'm sure I fell to the floor. That's a subatomic nuclear explosion. Okay, so let's sum this thing up a little bit. I said for years I've been showing that light spins in a circle. This now, they are saying, yes, it does spin in a circle. You can see it like that. And they're talking about the semi-Dirac fermions, which is that white particle that I showed you. And we created the white raw juice. All of this stuff is coming to be shown now. You see light spinning? You never heard of that before. They always said light flapped like a wave. No, it spins this way. It's exactly what light looks like. The particle is at the end, which is the up and down photon, and it spins. Some goes that way, some goes this way. That's all. And it's just a drill bit. So that's solved. It's not a flappy wave. They said the double slit experiment caused it to flap like this, like waves of water. No, it's spinning, and these white ones do not want to be next to each other. They splay right out like that. That's why you get so much energy. They hate each other. You get an enormous amount of energy in the front, and then it sort of dissipates as it goes. But this is like on a wall in the back, so we got to get in between here and before it starts interacting with all the other particles and starting to glow as light again. We got to grab the white. Now, I have so much on this, I could go on ad nauseum, which I probably already have, but this is that nuclear explosion, the subatomic nuclear explosion, created this interaction, which is exactly what happens in a nuclear bomb. The white comes out first, everything burns up and smokes, then the black comes, knocks things down. Preceding all that is this audible wave. It's called a whistler wave. You hear that, and then this stuff starts to come, and then as soon as it hits something, it'll just burn it up, and then a second later, boom, it knocks it down, because the black follows the white. This is a subatomic nuclear explosion. There's no other way to put it. And it's fission and fusion. No other way to put that either.